So for time series data, a simple example is this now function. We can just use it to extract what time is it, like the year, the month, and also the day and the time. And also because this specific variable is in date time variable, we can actually do calculations for different uh, date. For example, you might have already solved this kind of similar question when you first learn coding, like compute like how many days between 2 days, and also like today is March 11th. After 100 days, what is the date, right? We need to do the calculation by ourselves. But in Python, actually, if you just convert it using the datetime function, you can see this is a year, month, day, and also can give it a time, like say 8:15 in the morning, and we can directly compute the difference between two time day, like how many days between them, and also like how many seconds remaining. And another way is we can use a time delta function. It can convert a number into a time date variable. This way, we can just add up an integer to an existing date. For example, here, this one, the default way is days. So 12 this time, instead of a number, it means 12 days. So we can just compute like after 12 days, what is the time? So that's how like a basic Python to do with data time variable. But a more important thing is in pandas, we can use this date time variable as index for each data frame. So let's see. So I load these packages and I create all these different date time variables and save it in this list. And I use, instead of using like integers as index, this time I use all these dates as index. You can see when I run the program, now this is the output. And this series is like for each day, we have a specific value for it. And of course, we can still use the index from based on the integer numbers to get to retrieve the data, but also we can use human readable like date strings to extract those data. No matter is like in this format or like in this format, pandas will just understand how that means and extract the corresponding information from this series. Yeah, and another another example is this one. So assuming I create a very long time series data frame, and this one I generated 1,000 random integers, 1,000 random numbers, floating point, and then I generate 1,000 date time variables and use them as index. Here, this date range function is a function used to generate these different date times. I will also explain it later. So basically, the result is a 1,000 row series, and the index is just a different date. And because by default, the date range function we will create based on the day. Like each day, we just create a new time date time variable. And let's see if I want to retrieve information from just the year 2001, I can just give it 2001, and all the information related to that year can be extracted. And also, if I just give it a month, so all the information for May will be extracted. This will be very convenient, especially in the economics field, like you want to specifically focus on data from a specific period. And also, if you want to get information within a specific range, you can just give the date of that specific start and end of that range, and the information can be extracted. Yeah, of course, because it's a time date, right? So we know sometimes for like today I measure 3 data points. Maybe tomorrow I just have 1 data point. So it's possible that there is duplicate index. So if, for example, this one, there are some duplicates index, and it is totally fine and we can use the .index is unique function to check if the index there's a duplicate. If it's false, it means there is duplicate. And if I just want to retrieve the information on this specific day, I can get all the data points collected on that day. And also, uh, we created that longer time series data frame using that date range function. So this function basically you can give it a start time and end time, and the default frequency is by day. So it just increase one day by another and give you all the time daytime index. And of course, you can also just give it a start day and using the period parameter to say like how many index you want. It can just create based on that. And similarly, the default is just increase by one day. And you can also give it the end date, and you create the index backwards, and create this 20 daytime index for you. And it also takes many other like parameters. So for example, here frequency BME means business day, and ME is monthly end. So this is a very common terminology in business area. Like sometimes for every month, like at the end of every month, they will do some calculation and for the price and earning those things. So month end is a typical you can say just now still whereas so all these daytime index, but this time it's just every month and by the end of the month, like the last day of the month. So this table only summarizes some commonly used parameters, and in the future, if you have if you need to analyze this data, please check their menu. There are actually very many different kind of parameters you can use. And another thing about time series data is about time zone. We know Toronto, we just changed the time last Sunday. Yeah, so it's very unpleasant to work with this thing. But the good thing is in Python, we can use this pytz library to handle time zones. And usually people just convert whatever time zone, just convert it to UTC time and then do calculation. This way it can be like a uniform way to compute time. And but the default, like the previous time TS data frame, I think where is it? Create, yes, like the one I created at the very beginning. Yeah, this one. Default, there is no time zone. Like we didn't say what time zone it is, so it's none. But we can definitely set the time zone use a tz variable in the data range function. And we can also use a tz localize to convert, to set up the time zone for a specific time series index. And we can definitely convert it to another time zone just using tz convert. And also, by default, everything will just be converted to UTC if you want to do some time calculations. Yeah, that's some basic information about time series data. Another thing about time series data is like usually the data set when we collect it, maybe it's like every 5 minutes or every day. But when we do analysis, we just want to know like what is the average data in 1 month. So we can basically just for all those data sets, we can just do some average calculation and narrow down to like every month, just give a one value. So we can actually do it like this. So this is like a data frame that's from January 1st to April 9th. Every day there's a value. So we can use a resample function to like downsample the entire data set into a monthly basis. So here ME still means like month end, and mean means like we just need to calculate the mean value in that specific month. So after this, now there's only 4 entries each month there's a mean value for that specific month. And this idea is called downsampling. It's like a lot of data sets just narrow down to a smaller group of data points. And similarly, we can this is the data set for like every minute, and create like a 12 data set. Every minute there's one value, and we can narrow it down to 5-minute range. So now it's like every 5 minutes, what is the cumulative results? Because I use sum, so it's like a cumulative results. But this actually this is actually a tricky part. It's like sometimes like in their field, this calculation, like you can see here is from 0 to 11. We only have like 12 time points. But after like these results, you can see there's 0 to 5, 5 to 10, and that's it. There's no. That's because like they use this kind of window, like every 5 minutes, so it's like 5 time points, and you can do it like from the left side 5 time points and next 5 points. You can also compute from the end of the list. I mean, of the time series index, like the last 5 and the last the second last 5. So these two parameters, closed and the label, actually determines like how this thing is computed. So, for example, this one closed from right, it will just compute from the end of the of all these index, and but this one is a label from right, so it's not, instead of compute from the end, it just also extends this index and all the way to 15. I mean, so basically just from 10 to 15 and 5 to 10, like this kind of way to do the calculation. I know this is tricky, but yeah, it's just a way for the function to compute the to do the downsampling. Just be careful when in the future if you need to handle this kind of data set. Another another thing about, I mean, we have downsampling, of course, we have upsampling. So upsampling is like maybe you have 5 time data point, you just increase it to 50. But let's see this example. We have two date, and every city has a value. If we use similarly use a resample function, but we use a as_freq function to upsampling it, you can see there are many NA values. That's because we don't have data on those days, right? It's like a fake, nothing is there. So of course it's NA. So similar to that remove NA function we learned earlier in this course, we can use a forward fill to change, I mean, to fill those values. Just all the values just equal to the day on the first day. But of course, I mean, this kind of it's not true. It's fake data, right? You only do it if it's okay in your field, or maybe you can like assuming like there's some kind of strategy, maybe using the average to fill those values. That's also one way to do this upsampling. So the thing is, I mean, this is for like, this example is for like economic area, like, you know, downsampling. But actually in machine learning, in data science, downsampling and upsampling is also a very popular idea, because especially for upsampling, usually you have some techniques, like you have a figure, like you do want to do image classification, and we only have like 1,000 images, but I can rotate the image 45 degrees. It's not the same, but I mean, it's the same image, but different. When you rotate it, looks different. This kind of way, you kind of increase the all the image to another new one, and also maybe you can change the resolution of the image. You just reduce the resolution and make it blurred, and that's also another kind of image. This kind of way, like there are many ways to do this kind of upsampling in machine learning, like more smart than this kind of forward fill. But of course, that's still like a fake data, but we know that the rotate doesn't change the quality of the image, right? So and downsampling, I would say, is more used in there's an idea called imbalanced classification. that can, for it's very common in the medical area. Like maybe you have 1,000 healthy persons data, but for cancer patient you only have 10. If you compare this 1,000 with 10, the model can like have errors because there are too many healthy patients. The model just don't know what a cancer patient look like. So we can do downsampling, just randomly select 10 patient, 10 healthy person, then compare with. That's a very commonly used strategy to make sure like a different group has the same number of samples. This way, like the model can correctly learn the patterns within the dataset. So any question about this time series? Okay, let's see a simple example analysis, the stock data, like how we can analyze some real life like time series data. So this is an image got from the VOO. This is a S&P 500 ETF in the US stock. And you can see it's usually for a stock, it has a open value price, like in the morning, 9:30 when the market opens, what it is price, and also in like what is the highest price, what is the lowest price today, and also the volume, like how many stocks are there on the market. So of course, all these points on this curve show the price of this stock in this here is 1 year, like in this 1 year range, what is the price is. So we can actually do some similar analysis using this data. So I have a data set called stock data, and I just read it using read CSV. You can see I use the date column as the index. So now this is like a time series data. Each index is just a different day. And similarly, we have open price, high price, low price, and also the volume. This column is nothing, like means nothing, just only, so we just remove it. Now it's a clean data frame and we can draw some curve. First, let's check like what is the highest value change based on the date. So I use the line plot X, like the date as a index, sorry, X-axis, and the highest value as a Y-axis. Yeah, you can see this is kind of how the stock changes in different months. Is month? It's different day. Yeah, but some like in our previous question, like we can use resample to downsampling the data set. So here ME to like a monthly end. So we don't want to check like the everyday change. I just want to know every month what's the average value in that month. So I just downsample it, compute the mean, and use a mean value to check how the stock price change every month from 2006 to 2018. Yeah. And also, I mean, this just shows the highest value. We can also, sometimes we want to know like how the stock changes, like what's the difference between every time points. So we can use this function called .diff. It basically computes for every data point, it computes its difference from its previous data point. This way we know, instead of knowing the actual value, we know how it changes, right? We want to know like how the pattern of the entire stock. So we can compute the difference and then similarly still using the time as the x-axis, but now we can say, okay, in 2008, there's like the famous like the economic crash. Yeah, so there's a huge changes, and in other years maybe there aren't any changes. Yeah. So the last commonly used technology, not technology, I mean analysis way is called moving average. This moving average is like you use a window, like for example, 120 means I use a window that computes the average value of 120 data points. And then I move next, move to the next index and compute the next 120 values. What is the average? This way, it's like using this window, instead of check the actual value in that date, I can see a kind of average pattern in this along this whole time. So the function for calculate moving average is called rolling. You just need to give it the window size, like how many data points you need to compute the average value each time. And then it's kind of way to smooth the curve and make sure like it reflects more like the patterns within the data set to give you like a hint about how to like how should you proceed with the stock? Should you buy it or should you sell it? Yeah, that's basically some commonly used functions and strategy we can do with time series data. It's I mean, it's very popular or very common in economics. Maybe in other areas, it's not that common because, especially in medical area, we wish we can have time series data, but it's not possible. It's too expensive. So, but yeah, if you have in the future, if you find any job in this area, you might need to handle with this data set. Yeah. Any question about time series? No? Okay. Um, so the next thing is machine learning. Um, Before I start, in the session this morning, many students they attend the machine learning course last term. Have you ever turned that course? Okay, then yeah, then I will explain it. Yeah, because this morning they already learned everything. I was yeah, so so yeah, let's see how machine learning works. First, before I show the script, like how to use the scikit-learn package, I would like to briefly explain machine learning. So this graph shows basically what machine learning is. The thing is, um, let's say I have some images for dogs and I have some image for cat. I just gave all the images to the model. The model learning is like it learns the patterns within these things. And it's basically just a function try to figure out how to do prediction for these model images. After that, once that's trained, we call this process training. Once it's trained, we can give new data image to the model, and the model can tell us what it is. It's a dog or it is a cat. So it's just a pattern recognition. This image in this example, we usually call it instance or like a sample example. And based on how the data is given to the model, there's a supervised learning and the unsupervised learning. And supervised learning is just all the data is labeled. I mean, label, which means like, for example, an image, I will tell the model like this is a dog. I could also say this is an animal. Like this specific the tag for this image is called the labels. Yeah. Mm. And of course, unsupervised learning is just no labels. For example, you just gave all the image to the model and the model learns whatever it can. It could be anything. It depends on the model you use. So a typical example is this. This is a image classification data set. It has like a 60K images and all these 10 different type of images. Yeah, you can see there's dog and the truck and the cars. So if I give all these images and their corresponding labels to the machine learning model, the model can just fit all the images and learn what is all these categories, what is the pattern is. And once it's trained, giving some new data set, new images, the model can do classification for us, like to predict like this is a plane or this is a car, just it. But one thing about supervised learning is its prediction is based on the label we give. Like the previous one, I gave the 10 labels like image, it will just predict dog, plane. But if I just say like these are metal and these are animal, these are metal, like its shape is a metal. This way, the same image, just different labels, the model can only give us prediction either is metal or animal. It doesn't know the specific type the image is. So that's why it's called supervised learning. It's like kind of we teach somebody something and it can only learn this kind of thing. So these two examples I just showed is called classification. That's because the labels is categorical values. Yeah. But there's also another kind of problem called regression problem. It's like the label is a continuous value. For example, on the Kaggle website, they have a data set to housing prices. It's like for each house, they measure like 79 features, like the location and the size and like format of the houses. And also, of course, each house, there's a price. And then you can just give all the data to the model. The model can then do prediction for you to predict the final price of each house. So this kind of problem, we call it like a regression problem. So because like, I mean, regression is not a categorical prediction. The actual prediction is a value. So for this kind of problem, usually we compute the mean square error. Basically just compare the prediction price with the actual true price and find out what's the difference between them. Of course, the smaller the difference, the more accurate the model is. And you can see on Kaggle, they actually have this, for each data set, they have a computation. And you can submit your model and check what is the performance of your model. So this one, this group is ranked first. And yeah, actually for the final exam, some students, they don't want to choose project one. They want to choose their own data set. So Kaggle is a very good resource. You can see their examples, download their data set. Actually, the project one, the data set, I just downloaded from Kaggle. Yeah. Yeah, that's supervised learning. Basically, you just need label for all the data. Another type of learning is called unsupervised learning. So yeah, apparently the algorithm are not given any labels at all, and the model just learn it by themselves. And specifically, there are three types: clustering, association study, and dimensionality reduction. So clustering is just this kind of algorithm just group all the samples to different categories based on their similarities. For example, all these 10 images, okay, the model may just divide it into all these different groups. Each group represents a specific type or car or a cat in that. The thing is, the model actually, I mean, let's assuming it just divided into 10 groups, the model doesn't know what each group is. It just tell you like, okay, these images should be the same, but it could be a shape or it could be a cat. The model doesn't know what it is. It just tell you the other in the one groups. And another another type of unsupervised learning is association study. Basically, it's like it's very commonly used in like Amazon or all those websites. They collect all the information, like you buy something and the history, and then they can do suggestion like people like you, if you buy a cell phone, if you buy a headset, maybe you will also like to buy maybe a speaker or something like that. Yeah, it's kind of there's a kind of association between these kind of histories. And and the last one is dimensionality reduction. So this one is like it reduces the number of the features in the data set. For example, this housing price problem, each house has 79 variables. But actually, if you use dimensionality reduction, you can see maybe just the two variables or three variables can give you an accurate prediction. Yeah, I mean, depending on the problem, it is different, but it's quite useful, especially in when sometimes you might have like a million features, you want to reduce it to 10,000 features, and dimensionality reduction is what you want. To summarize, so machine learning just have supervised learning, unsupervised learning, and the only difference is just if label information is provided in there. But of course, like some latest models, actually they can take both labeled and unlabeled data at the same time. So they can learn from unlabeled data, and this process they call it pre-training. It's like you just don't tell what it is. The model just learn first, and then you can give it some labeled data, and this way they have proved that this kind of process can give you better performance. Yeah. Uh, so let's see an example. So you are given a data set of emails. Each of them are labeled as spam or not spam. So your task is to build a model to classify them for new emails, like to check if it's a spam or not spam email. What do you think? If is this a classification problem or unsupervised learning? Yeah, that's correct. Yeah, because we need to kind of group them to spam and not spam, and there's a label for the input, so it's a supervised learning. And similarly, and this one, next one, we have a collection of Lego pieces of different sizes and colors. You want to organize them into different groups so that it's easier to build the set. But you don't know the part number of each piece. Assuming like you don't have the menu, just you want to put them into different boxes so it's easier to for your to assembly the set. What do you think? Is this a supervised learning or unsupervised learning? Right. Yeah, that's right. It's unsupervised learning. Yeah, clustering. Yeah. So it's just put into different groups. Yeah, just based on the size and the look of them. Yeah, that's all about machine learning. And any question about them? So before I show you the script, let's see some idea about matrix. So a matrix is just a way to measure how the model performs. And so for example, accuracies, we know like, and also the precision recall, those are just a way to show like, okay, my model works best. Of course, 100% accurate is a goal we want to achieve. Um, Also, we can use accuracies, I mean, matrix to determine if the model is overfitted or something. Oh, by the way, this idea overfitting, it's like usually for a data set, we will divide it into several groups like training data, validation data, and the testing data. And this because a model has some parameters, we want to tune the model, like use the best parameter to achieve the best result. But we don't want the model like sometimes if you like you just let the model learn on a small group of data, the model learn it so well, like uh, everything on that data set it's 100 accurate, 100% accurate prediction. But give a new data set, the model doesn't know, like the prediction is wrong. This kind of behavior is called overfitting. It's like the model just fit the data you have. It doesn't learn the actual pattern. So we can just usually we use a validation set to tune the model and use a test to check the performance of them. To compute those matrix, you need to understand these four terminologies, like true, positive, false, negative things. So this is, I think this is very confusing at the first time. Like I feel confused because it's this terminology. But the thing is actually just so true positive means this thing is positive, and my model predict is as positive too. So it's like a true positive. Yeah, true negative is this thing is negative and predicted as negative, and my model is correct. So that's how similarly like a false positive is just is false prediction. And so based on those four terminologies, we have all these different kind of matrix like accuracy, precision, recall, F1 score. It's basically just different ways to show you how the model performs. And so we will show it later in the script. As Python has a classification report function, actually can compute all these things for you at one time. Just yeah, one function calculate everything. And also there's an idea called ROC curve. So similarly, there's also an idea called precision recall curve. This is like given a prediction. For example, you have 100 samples, you have 100 prediction, but the prediction is like not a categorical value, but a numerical value, like a probability, like 80% or 90%. Like you can then define different threshold. For example, you use 10% as threshold, you can compute a false positive rate and a true positive rate, and then 20% compute another rate 10%, 30% communal rate. This way, like different threshold, you can get a different point on this figure, and all these points can follow, can generate a line, a curve. Similar to that, it's like a different threshold. You can compute a recall and a precision, and another threshold, another threshold. This way, like instead of directly give you like a performance, you can use this way to check like overall how the model performs. Sometimes like uh, for example, your prediction is a probability like 90% positive, but in real life you don't know like if 90% positive is positive or negative. Yeah, sometimes maybe 99 is should be positive. Sometimes maybe if it's larger than 50%, it should be defined as positive. So this way, you can't tell which threshold is better. You can just use this way. As, as long as I compute every threshold, I can know like my model performs overall okay. For this one, it's like because this curve is like this one is like the more it's closer to the upper left corner, that one is the upper right corner. Like the more accurate the model is. So this area under the curve is a way we use to check the performance of the model. These two figures are frequently used in nowadays like academic papers, because for papers sometimes we want the paper looks good. A plain table might looks too simple, right? We want something colorful, and I think that's very many people, right, they choose using these figures. And also, I mean, these things are for like classification ideas. And for regression, we can use mean square error, mean absolute error to compute the difference of the predicted values. Yeah. So as for which matrix to choose, like, of course, I mean, ideally you should choose the best method based on the topic you want to I mean, you want to achieve. But the thing is nowadays, like even if you choose the best matrix, others, the readers, they will still ask like you like, okay, how about the other matrix? What's the model's performance on that? So a commonly used way is just I just do compute every matrix and list all the results there, so that it's more clear, shows that my model works good. Yeah. Yeah, that's all about the matrix part. Any questions? Okay, let's see some script then. So this one. Uh, so in Python, there are many packages for machine learning, and also deep learning. But this scikit-learn is the most popular and most user-friendly for beginners, because its format is very simple, and it has all the classical models like random forest, support vector machine. And it's so simple, like you don't even know, you don't even need to know like what the model is, like what the mathematics is. You can just do prediction, training, and predict in just 2 lines. So we will see how it looks. So let's load the Aries data set first. And so yeah, this is a plot we show like last week. We can see this data set has 3 different type of flowers. And there are 150 there are 150 flowers. Each flower has 4 features of different lengths of the iris. And so let's to do the test, we first use train test split. This is a function in scikit-learn that split the data to training data and the testing data. So usually in Python, we use X to represent the data and use Y to represent the label. So it's like train data, train label, test data, test labels. And we use a model called Gaussian negative binomial model. So you can see just 3 lines. We first define the model and save it in the variable model, and then use model.fit, training data, training labels, and then model.predict, testing data, and this is the prediction. And this is all the same for all the models. Like all you need to do is to change this line, maybe to random forest or like to linear model, and all the remaining part is the same. Yeah. And once we do the training and predicting, we can use the accuracy score to compute the accuracies. So similarly, this is like the testing labels and the predicted labels. You can see the accuracy is very high, like 0.9897, because that's the average data set. It's a simple data set. This is like a supervised learning. And we can also do unsupervised learning. Using this function called PCA. Have you ever learned PCA? No. Good. PCA is like its full name is called principal component analysis. It's like we believe that in a data set, no matter how many features it has, it should have some like some principal component, like maybe like I mean, depending on how many compute component you want to compute. Let's say here is n component equals to 2, means I just want to use the most two variables that can discriminate this data set. And instead of the whole like a 4, yeah, of course, I mean, in average data set, there's originally it's 4. I just now divide it into 2. But for example, for the housing price, we can also do it like even it's 79 features, we can, instead of 79, if I just want to use 2 features to represent the data set, what it should look like. Of course, I mean, this this principal components is not the original features. It's like it's like a computed features. It not exist in the previous data set, but we can see actually. I just divide into 2 components, similarly fit. And oh, by the way, this one, because this is not it's not prediction, right? So it's super unsupervised clustering. So we use the transform function. You can see. I mean, this PCA1 and PCA2 is not the original feature, but actually just these 2 features, it can like clearly separate all 3 kinds of flowers. So this component is like a computed feature based on the original data set. I didn't I didn't explain the mathematics here. So usually, but you can think of principal component as the component that reflect the variance in that data. So the PCA1 should reflect the most significant variance in that data. Of course, PCA2 is the second most important variance in the data. Yeah, that's how like a PCA means, like intuitively. We can also, I mean, this is just a dimensionality reduction. We can also do clustering. We use a typical function called k-means clustering. And so for this clustering, you need to give it like how many cluster you want. And similarly, you do fit and predict. But because this one, you need to give the actual cluster for each sample. So you will use a predict function. And let's draw this figure again. And now these 3 samples, all the flowers are divided into 3 clusters. You can see there are some mixed classification. Like this one, it should be Virginica, but it's actually in another cluster. That's because k-means is just a very simple algorithm. K-means just calculate the similarity of each samples. It just put everything on a space and compare the similarity of every samples, and just arrange all the similarity and then put like these 100 samples, their similarity is very small, put them into one group. those ones, they are very similar in another group. So it's a very basic way to compute the similar, to clustering. So that's why its performance is not so good. And also you need to specify how many clusters you want. If we change it to like 5, yeah, it can still do clustering for us. Even though these two, they should be, these two, they should be different cluster, but they are still grouped into one cluster because k-means thought they should be similar. Um, so let's see another complicated example. So there is a data set how so called means data set. It's a group of handwritten digit. It's basically just the human written digit numbers. Maybe I can show it here. So we can use the load digit function in scikit-learn to load that data set. And you can see each image is just 8 by 8 image and the pixel image, and there are 1,700 images. We can show how the image look like. So these are just the different handwritten digit, very blurred. It's because they are like enlarged, and you can see this is 0 and 9. Yeah, these are their corresponding labels and how the image look like. So we can change the data to, because this is kind of like each image 8 by 8, and then it's kind of a 3-dimensional data, but we want the data set to be like a 2-dimensional. Yeah, so just the sample and feature. So we just align all the cells, align all the pixels in one row, and then make it into a 64 feature image. And the target is all the labels of that image. We can first, we change it. This is another way for dimensionality reduction, but this one is a non-linear model. ECA is a linear model. It's like a most simple model. We can see we still fit it and transform it and check the scatter plot of the results. You can see even though it's just a 2-dimensional features, we can actually kind of separate all these 9 digits images. And we can also do classification. We split it into train and test. And oh, I forgot to mention this. So this train test split is a randomly train test split. Like randomly select maybe 80%, or I didn't set it, but what's the default value? Oh, if train size 9, it should be 0.5. Maybe certain. So yeah, so the percentage is like 75% is training data and 25% is testing data. So it's randomly choose. So this kind of is this kind of selection is based on the random generator in the computer. So usually, if you don't set it, it will just use a randomly number. So this time today you run it, you get one result. Tomorrow you can get another result. So if you want to get a fixed result, you need to include this random state. So like give it give it a fixed random generated number. This way, no matter when and where you use this function, the results is always the same. So we split it, and then similarly, we still use that Gaussian negative binomial model, fit the model and do the prediction. And you can see the accuracy is 0.83. That's because, this model is not a very good model on this classification problem. And we can check using the confusion matrix function to check what is why I got the wrong accuracy. So you can see the confusion matrix basically based on the true value and the predicted value. It can tell you like, okay, this one is wrongly predict and this one is wrongly predict. Yeah, just using a heat map to show like which results are not correct. And but of course, we can, I mean, this can show the wrongly predicted value. We can also label the original image using the script here. And you can see this one is wrongly predicted. So let's see, I don't like the model. I just want to change it to support vector machine. So I just import another model from scikit-learn. And this is actually one way to use support vector machine. So if you search SVM, you can see there are many functions like linear support vector machines, and also SVC. This one is it can use other kernels and to more complicated support vector machines. So basically, if you want to use it, every function you search its menu, there is an example. All you need to do is to copy this line, and that's it. You can just exchange it and use it in your program. And we define another model and fit on the training and testing data, fit on the training data, predicting on the testing data, and use a classification report to generate all the matrix precision, recall, and F1 score. You can see this one is more accurate. For different images, it's almost 100% accurate. We can also, let's see another example. We can use another model, this logistic regression, to fit on the training data and do the prediction. And because the logistic regression model actually produce the prediction results of probability. So I want to use that probability to draw this RC curve. So because RC curve is only for like a binary prediction, so you can only do this kind of one versus another. So here I just give like this is a Y label I choose for the number one, like what is the prediction? What is the true value for number one? What is the predicted value? And then this RC curve display function can just draw a RC curve for us. You can see the AUC is 0.99. And this one, this dashed line, it means random guess. Random guess is usually just 0.5. So we can see this model also work good on this specific problem. Yeah, that's how, that's basically how we can use scikit-learn like to do machine learning models. In our final exam, there's both two questions requires you to use 3 different type of models to do the prediction. If you are not familiar with them, you can just search the menu and just copy the code from here. Yeah, and that's it. Yeah. Any questions? No? Okay, so we have a tutorial question. So this is also another data set, like a database from the UC Irvine. We have a machine learning repository. So you can download the data set from there and build a random forest model to classify one quality based on the data set. I will give 15 minutes for everyone to give it a try, and I will then explain how we can do it. Okay, let's see how we can solve this problem. This data set is I have already downloaded from on my computer. It's a little bit weird. It calls CSV, but actually uh, is separated by semicolon, not comma. So to read the file, we can use specific set using semicolon to to separate the data columns. And to make it easier, I mean the question asked to predict the quality, I just convert the quality into a binary label. If it's larger than one, we say it's larger than seven, we said it is okay, one. Otherwise, this is not okay, zero. And so then we remove the original uh, column, the quality column, and also change that to a y as the predicted value. And we can check the data. This is just a data frame, and uh, each row is the information we want, is a feature, and the y is labels we use to predict. And assuming I'm a beginner, I don't know how what is how to use a random forest model, so I can just search random forest. I see a scikit-learn. You can see here it has the example showing how you can do this. Yeah, it's here. You can just copy it here and then do some. So yeah, we don't need this. This is just the generate a random data set for you to test. So we want to, this is a function used to define the random forest classifier. And we also need a xtrain, xtest. We use a train test split function to divide it into training and testing data. And your test size 0.2 means like 20% of the data is left out for testing. So we then revise this one to X train, Y train, and we can Y predict equals to CLF predict X test. And we can also use the Y predict probable as the predict probability for this data set. So this is also one special thing about random forest. It's like it can do actual prediction for you, like give you a label. It can also give you a probability. Just depends on how you want for the specific, what kind of value you want. And after this, we can write and it's done. We can then use the matrix, the classification report, yeah, function, giving it the true value and the predicted value, what does it look like? You know what? I forgot where is the classification report function. Let's see how we can find out it. It should be in the oh, it's just I use the wrong character. So let's change it. Classification report. And I just replaced it here. Yeah, gave us the prediction results for this model, all the precision record. And we can also copy that RLC curve function to show how the RLC curves look like. All we need to do is to change this one. This one is Y test. And this one is Y predict problem. Yeah, that's because yeah, this is the RLC curve. Yeah, I got that error because this predict probable is actually the result is a two-dimensional matrix. We can have a look at it. It's like the first column is the probability of being 0. Second column is a probability of being 1. So I just want the probability of being 1 and use them to predict, to draw the curve. So I can just do it like this. Yeah. This is how, like, if you're new, you can learn these things through Google and figure it out. Instead of using ChatGPT. We know ChatGPT is this is actually how I learned machine learning at the very beginning. I know ChatGPT is very easier, but this way seems stupid. But actually, if you try this way like two or three times, you will remember everything. But for ChatGPT, you can get the answer in like 10 seconds, but you copy it, you forget everything and still don't know what it is next time. So yeah, I personally still suggest this way to learn something. In the future, when you get a job, you can definitely use ChatGPT to help you with your daily work. But before that, this is a good way to learn. Yes. Yeah, that's all about today's lecture. Thank you.